Hello, I'm the Mathematical Mr. Daycock, and today I'm going to be teaching you about what to do when the area you're looking for is below the x-axis. So let's take this example here. As always, first of all, we are going to sketch a graph. To find the roots, to find where it crosses the x-axis, I'm going to need to factorize this. So I'm going to factorize it to x minus 3, x minus 6, and that tells me the roots are going to be at x equals 3 and x equals 6. So just put those on here, 3 and 6. And if we notice, it goes plus 18, and that tells me it's going to cross the y-axis at 18. And this gives me the curve looking something like this, approximately. Now, the area we're looking for here is this bit here. And as we can see, it's below the x-axis. So what's going to happen here? Well, nothing different to normal. We're going to do it exactly the same. We're going to use an integration from 3 to 6 of x squared minus 9x plus 18 dx. We're going to integrate exactly as normal. I'm going to use square brackets because we're doing a definite integral. And we've got x squared, add 1 to the power, x cubed, and then divide by the new power, it's 1/3 of x cubed. Here, we've got x, that's x to the power of 1. It's going to become x squared, and we need to divide by that new power of 2, so it's minus 9 over 2 x squared. And lastly, 18, there's no x on the end here, so in many ways it's x to the power of 0. So 18x to the power of 0, add 1, we're going to get 18x to the power of 1. And if we divide by 1, nothing changes. So we are done. And we're doing that between 3 and 6. Now I just need to plug in these values. So I'm going to get 1/3 of 6 cubed minus 9 over 2 times by 6 squared plus 18 lots of 6. And I'm going to subtract, plugging in the 3, 1/3 of 3 cubed minus 9 over 2 times by 3 squared plus 18 times by 3. And I'm subtracting all of that. And that works out as 72 minus 162 plus 108, subtract 9 minus 45 over 2, 81 over 2, plus 54. And remembering this bit here is putting in when we put upper limit, our upper limit, which is x equals 6, and this bit here is we're subtracting is our lower limit, which is when x equals 3, and we substitute those in to get these values. Working that out, we're going to end up with 18 subtract 45 over 2, and then doing a little bit of fraction subtraction, we're going to end up with 36 over 2 minus 45 over 2. And what you need to notice here is that we're doing a smaller number subtract a larger number, so we're going to end up with a negative answer, negative 9 over 2. Now, that's a little bit odd. Why is our answer negative? Well, if we go back to our original graph, we're looking for area after all. Area shouldn't be negative. What's going on is that we're looking for this part below the x-axis. And if we remember the way integration works, what we're doing is adding up lots and lots of little rectangles. And each rectangle is the height of the curve. But the curve at this point is negative. And so what we're doing is we're adding up lots and lots of negative values, very, very small negative values, but still negative values, which is not too surprising that we're going to end up with a value that is negative. Hence, to find the actual area, we just need to make it positive. We just need to take the absolute value of it. So the area is equal to positive 9 over 2. Okay, on to our next example, where things are going to get a little bit more complicated. Find the area between the curve y equals x cubed plus 4x squared minus 5x and the x-axis. So again, as always, we are going to sketch this. And as always, to find the roots, we're going to need to factorize. So factorizing this, first of all, I notice there is an x that can be taken out. So I take our x, And I'm left with x squared plus 4x minus 5. This here is a quadratic term, and so it can be factorised itself into double brackets, hopefully anyway. Fortunately in this case it can. And we're looking for two numbers that multiply to negative 5, add to positive 4. Well, that's positive 5, x plus 5, and negative 1, x minus 1. And so this tells me my roots are at, for this one, x equals negative 5, here x equals 1, and for the x in front, we can think of that as x plus 0, the root is x equals 0. And so plugging on our roots, negative 5, 1 and 0, you get negative 5 down here, 0 here, and 1 here. Now it's a positive cubic, so it's expected to start out in the lower quadrant and head up into the upper quadrant, and so it's going to look like this. And the area we're looking for are these two bits combined, the green bit and the blue bit. Now what is really, really tempting at this point is just to do one quick integral from negative 5 to 1 of our function y dx. But the problem with that is that the green bit's positive and the blue bit will come out negative. And if we just do the whole integral at once, then that negative blue bit is going to cancel out with some of the green bit and our area will be too small. To find the area, we're going to have to split this into two integrals. We're going to need to do the integral, the green bit first, which is the integral from minus 5 to 0 of our function x cubed plus 4x squared minus 5x dx, and then also find the blue bit, which is going from 0 to 1 of x cubed plus 4x squared minus 5x dx. Notice that the green bit goes all the way from minus 5 to 0, that's that length there, and the blue bit goes from 0 up to positive 1. And so these are our two integrals. What's of course quite nice here is that once we've worked out the actual act of integrating, the act of adding those powers to 1, is going to be exactly the same for the other one. So x cubed goes to x to the 4, and then we divide by the new power, so we get a quarter. 4x squared, we get x cubed, add 1 to the power, and then divide by the new power, we get 4/3. We've still got the plus there. Minus 5x, well, add 1 to the power, we're going to get x squared. Divide by the new power, we get minus 5 over 2x squared. And that's going to go from minus 5 to 0. Calculating that, plugging in the various values, well, 0, when we plug in the 0 term at the top, it's just 0. 0 of this, of each term, everything's just going to go to 0. And then we subtract, plugging in minus 5. So 1/4 of minus 5 to the power of 4. Notice the use of brackets to avoid issues with the negative. Plus 4/3 of minus 5 cubed minus 5 over 2 lots of minus 5 squared. And calculating that, that's going to give us 0 minus 625 over 4 minus, and notice here the reason it's coming out as negative is minus 5 cubed. We're multiplying 3 negatives together. The first two become positive, but then we get a third one which gives a negative again, minus 500 over 3. And then lastly, here we've got two negatives, they multiply together to become positive, but then we've got negative in front, minus 125 over 2. And that's just going to equal, working that out, we get 0 minus negative 875 over 12, which is just positive 875 over 12. So going back to our original part here, the area of this green bit is 875 over 12. Now we only do the blue bit, which is exactly the same, except our limits are different. So we're going to be integrating 1/4, well, We're integrating our original function, but what we get is 1/4 of x to the 4 plus 4/3 of x cubed minus 5 over 2x squared, all between 0 and 1 this time. And this works out pretty easily. If I put 1 in, 1 to the power of 4 is 1, so it's just going to become 1/4, plus 1 cubed is 1, 4/3, and 1 squared is 1, so minus 5 over 2. And then I'm subtracting, plugging in 0, it all becomes 0 again. So that's very nice. Now, working this out, this works out as negative 11/12, and that gives us our answer to this bit. The blue area is, well, not negative 11/12, but positive 11/12. And therefore the total area under the graph, the total area is going to be equal to 875 over 12 plus 11 over 12, which is going to be equal to 886 over 12, which simplifies to 443 over 6. And that there is our final answer. Okay. Thank you for watching. Hopefully you've got a bit more of a sense here of how negatives are going to affect things, and that will hopefully help you out with future problems like this.